So for this question, they ask you to find the first 3 non-zero terms of Maclaurin series, right, of cosine x. So if they never ask you to differentiate, you just use standard series. You don't care. Just use it. So then you eyeball the end game. The end game is x power 4. Okay. So whenever you do Maclaurin series, just understand where to stop. If you don't know where to stop, we check. Okay. So you just write it down. Yeah. So first 3 non-zero term of cosine x. So just follow what they say. First 3 non-zero term of cosine x. So this is the standard series of cosine x, right? We want the first 3 non-zero term, meaning to say the to power 4. So this case here, gx is cosine x about 6. Cosine x here. So this is it. Okay, so this is the normal binomial expansion you learn in secondary school, is power 6, right? So this is not power series. This is just this guy here, binomial expansion. This is given in MF27. Right? Just note that you have a binomial expansion here. So you just have to expand it, like secondary school style. So this case here, what we'll get is 6, 0. Okay, this is your replacement. You replace the x with this guy here. This one. This is your. So this is your A. This is your B lah. This is a binomial expansion. So we just get 6 choose 0, then 1 to the power 0, then minus half x squared plus 124 x to the power 4. Okay, this should be 6. This is 0. Then plus 0 choose 1, 1 to the power 5, half x to the power square plus 124 x to the power 4. You use binomial expansion when it's binomial when this is a positive integer, because there's a finite expansion. It's not infinite series now, so this positive integer will definitely be what you learn in secondary school. So 1. Now you stop where? You stop at square lah. You stop at square, right? You're gonna stop at square. Yeah, I stop at square because the lowest expansion for square will be power 4. That's where I want to stop. Okay, you go power 3, then there's no use because power. You start a cube, right? Expansion of cube, there will be the lowest degree is x to the power of 6. So which is not what you want. Just expand everything. This is 1. This is 1. This is 1. Obviously, everything is 1 here. This is 6. So it's 6 minus half x to the power half minus half square. X to the power 4. 6 choose 2. Calculator. This will be 15. Okay. In calculator, then you go to your GC. You see this function 2, right? F2. There's a C here, so you have 6 choose 2. So alpha F2. Then you go to number 8. So it's 6 choose 2. You get the answer lah. This is 15. So the lowest. You don't expand everything for the square lah. You can just take the lowest because the lowest is the power 4. This is negative 3x squared. If you expand it in, expand it also. There you go. Okay, there you go. Done. So this is the expansion. 2 part 1. Use 1 to give a approximate in terms of A. So you need to find an approximation in terms of A. So this is gx, right? Just copy the Maclaurin series. So because you just want the approximation. The reason why we use Maclaurin series is because for polynomial it's easy for us to integrate and differentiate. So this guy will be x minus 3x cubed over 3 minus 4 or plus x5 divided by 5, right? Then this will be a0. This is quite okay lah. So this will be a minus a cubed plus 4 over 5. 8 to the power 5. Get it? Then they ask if A is pi over 4, evaluate this approximation. So do that. So I just key in calculator. There will be roughly 0.540029 0.540 3SF. Okay. Use your calculator to find the accurate value of this guy lah. So you just use calculator. Just punch in calculator. key this in the calculate. You want the accurate value, right? So meaning you just press math, then function integral here. So number 9, then you just go to 0 to pi over 4. Then this one you put this as cosine x. Cosine x to the power of 6. You just want you to evaluate the number here. So you just key in. So this is 0.475. So because small is relative, okay, if you plot these two equations out, right, you realize that GC and plot it out. Okay, so if I plot these two equations, this is the exact curve, this is the Maclaurin series, right? So you realize that okay, I'm gonna just this is too far to see, but if you zoom box to this area here, now small is relative. The reason why it's not accurate because it's not negligible enough. Okay, so if I trace, I put pi over 4, right? I see that there you go. You see the deviation here. The exact curve is the blue color one. Then this one, the deviation here is very high. Okay, so pi over 4, so I trace pi over 4. Yeah. So the way you write it is basically because it's not negligible enough. So I think the keyword should be x is not accurate, right? As x is not small enough for x to the power 5 and above to be negligible. So from the graph you can see the deviation at pi over 4, there's a gap there. Okay, so that's the reason why.